I am Kapu Sravanti, lecturer in ECE, Government Polytechnic for Women, Warangal, Telangana. Today, the topic of my presentation is use of high voltage probe and current probe, construction of AC bridge and conditions for bridge balance. In the last class, you have learnt about understand the use of FET input voltmeter, construction of FET input voltmeter, operation of the FET input voltmeter, use of the differential voltmeter, basic circuit of differential voltmeter and AC differential voltmeter. In today's class, we are going to see the introduction of the DC bridges and AC bridges. Now let us see the contents of the second unit in our syllabus. Use of high voltage probe, clamp and current probe, construction of AC bridge, conditions for bridge balance, types of DC bridges and AC bridges, use of above bridges, resistance measurement using Wheatstone bridge, inductance measurement using Maxwell's bridge, capacitance measurement using shearing bridge, important errors and their prevention in bridge measurements, and limitations of AC bridge method for measurement of small inductances and capacitances. Now, I will focus on the topics, that is use of high voltage probe and clamp and current probe and construction of AC bridge and conditions for the bridge balance and the applications of AC bridge. Now let us coming to the high voltage probe. You can see the pictures of the high voltage probe here. If you observe clearly, you have seen what you can see. You can see the probe, that is a probe tip. It consists of a probe tip and probe head, and there is a termination circuit and that is connected to the device. What is the use of high voltage probe? A high voltage probe is used to measure high voltages in the order of kilovolts. A voltage division of 1000 to 1 may be used, which means that attenuation 1000 to 1 may be used. The probe head is made of high impact strength thermoplastic material, which is of special design used to protect the user from electrical shock. That means the probe head is made of thermoplastic material because to protect the user from the electrical shock. Now you can see the block diagram of the oscilloscope probe. It consists of a probe tip and probe head, and there is a coaxial cable and termination circuit is there, and next the final device, that is a final part that is connected to the scope. Now coming to the internal circuit, that is the circuit diagram probe input, and it consists of a probe head, that is 100 mega ohm, and there are 3 capacitors. By tuning we can adjust the probe attenuation, and next there is a cable, coaxial cable, and termination circuit is there, and here resistors and capacitors are connected, and next finally that is connected to the device, that is nothing but oscilloscope. High voltage probe construction. The construction of high voltage probe you can see in the figure. It consists of a 100 mega ohm resistor in the probe head. You can see in the figure, that is a probe head, that is 100 mega ohm. This is connected to the termination and through a special cable. You can see in the figure, that is that probe head that is connected through the cable to the termination circuit. And how the probe compensation can be done by using the network R1, R2, C1, C2 and C3. You can see in the figure R1, R2, C1, C2 and C3. Here the termination circuit is there. You can see by using this we can adjust the probe compensation. And next, the probe cable terminates in its characteristic impedance by resistors R3 and R6. Here R3 and R6 we can see in the figure. By using this we can simply terminate the circuit, that is in its characteristic impedance. Okay, now let us move on to the limitations of the high voltage probe. That is, it requires large isolations and bigger size, and which is not suitable for high frequency and closely packed components, and shunting capacity of input circuit and increase in temperature. These are all the limitations of the high voltage probe. Now coming to the clamp on current probe. You can see the different pictures in the figure. Here the current probe, that is there is a clamp is there. Clamp on current probes or current clamps, they enable to measure currents without breaking the electrical circuit. Current clamps are designed with the jaws. You can see the jaws that can be opened, placed around the conductor and clamped shut to form a magnetic loop around the conductor. The current clamps offer a safe, cost-effective, simple and accurate way to take current measurements. So these are all the advantages of the current clamps, which means that safe measurement we can take by using this current probe, and simple and accurate way. Accurate way means we can get the accurate value of the current value. Okay, so now current probe, here you can see the diagram is there. There is a conductor and a clip-on head and 5 feet cable and amplifier, and 2 feet cable is there, and there is one AC voltmeter. So coming to the construction, current probe is similar to the current transformer with a difference that the iron core is replaced by a ferrite core, which means that current probe and current transformer both consist of a core, but there is a core difference, that is iron core is replaced by a ferrite core. Current probe simply clips around the wire carrying the unknown current. So, which means that this probe provides a method of inductively coupling the signal to the scope input. Hence, the direct electrical connection to the test circuit is not necessary. That means completely inductively couple the signal to the scope input. Hence, direct connection is not required or not necessary. So, this probe can be clamped around a wire carrying an electrical current without any physical contact to the probe. Hence, thus the magnitude of current with a frequency range from DC to 50 MHz can be measured by using this probe. So, the current probe consists of clip-on head, you can see in the figure, and amplifier which can be used with the AC voltmeter. You can see the clip-on head, and there is an amplifier, and you can see the amplified current that can be connected to the voltmeter. That voltmeter directly reads the current. The current probe simply you can see in the figure, that is clip-on head consists of clip-on head and amplifier. This amplifier can be used with the AC voltmeter. The probe is effectively a current transformer, and it has the property that it will sum the instantaneous values of current in two or more conductors that it may be clipped around, which means it has a summing property, that is it will sum the instantaneous values of the current in two or three conductors that it may be clipped around. Okay. The wire which forms one turn of the primary of a transformer and the secondary of many turns is wound on the ferrite core of the probe. And the voltage induced in the secondary of the probe is amplified, and the amplifier output voltage is measured by a suitable AC voltmeter. Um, Basically, we have already discussed because the probe is a current transformer. So, according to the transformer property, if the voltage or current induced in the primary, it also induces in the secondary by the principle of the mutual induction. Hence, the voltage induced in the secondary of the probe that is connected to the amplifier. Hence, the voltage is induced and the amplified voltage is given to the AC voltmeter. Okay. Finally, the AC voltmeter shows the reading. The amplifier is designed so that 1 milliamp in the wire being measured produces 1 millivolt at the amplifier output. So here the amplifier completely 1 milliamp amplifier is produces it produces 1 millivolt at the amplifier output, and the current is then reads directly on the voltmeter using the same scale as for voltage measurement. Hence, there is a AC voltmeter. The current, whatever it may be produced and the amplified output, then that is directly shows on the voltmeter. This is about the construction of current probe. So, this current probe generally it consists of a magnetic core and with a removable piece which is used as the coupling element for the current probe. The wire carrying the current to be measured, that is inserted in the center of the magnetic core and acts as a primary of the transformer. The core is a ferrite U-shaped core, and a multi-turn coil of approximately 25 turns is wound on one leg of this core, and this works as a secondary of the transformer. Because of electromagnetic induction principle, whenever the current flows through the primary, the EMF gets induced in the secondary. This is fed to the scope input via secondary circuit. Okay, that is about the transformer based current probe. Okay, now let us move on to the next topic, that is bridges, construction of AC bridge. Before going to the bridge circuit, I want to give the introduction about the bridge circuits. So, bridge circuits are generally used for the measurement of resistance, and that is called a Wheatstone bridge. A bridge not only measures the resistance but also used for the measurement of various components values like a capacitor and a inductor, etc. Okay, so previously we have seen that ohm meters and ohm meters we have seen based on construction, that is we have seen series type ohm meter and shunt type ohm meter we have seen, and now by using that series type ohm meter and shunt type ohm meter we can measure the resistance, but by using that ohm meters we can't get the accurate values. Hence that means low accuracy compared to the bridge circuits. By using bridge circuits we can get the accurate values. So a bridge circuit consists of a network of 4 resistance arms forming a closed circuit. A source of current is applied to two opposite junctions, and the current detector is connected to the other two junctions. The bridge circuits use comparison measurement methods and operate on null indication principle. The bridge circuit compares the values of unknown component with that of an accurately known standard component. Thus, the accuracy depends on the bridge components and not on the null indicator. Hence, high degree of accuracy can be obtained. In a bridge circuit, when no current flows through the null detector, which is generally galvanometer, the bridge is said to be balanced, which means that when the bridge is said to be balanced, which means that when no current flows through the null detector or that is or galvanometer, that is, then the bridge is said to be balanced. The relationship between the component values of the four arms of the bridge at the balancing is called the balancing condition or balancing equation. This equation gives us the value of the unknown component. So, the bridges are two types, DC bridges and AC bridges. DC bridges are used for the resistance measurement and AC bridges are used for the measurement of parameters like inductance and capacitance. Now, let us move on to our next topic, that is construction of AC bridge. Here you can see the AC bridge, that is it consists of an AC bridge. It consists of four arms and a source of excitation and a balance detector. So each arm consists of impedances, and the source is an AC supply which supplies AC voltage at the required frequency, and balance detector, we can use the headphones and tunable amplifiers and circuit and vibration galvanometer. These are all used for the balance detector. One is headphones and tunable detectors and vibration galvanometer. For high frequencies, electronic oscillators are used as the source, and balance detectors commonly used for the AC bridges are headphones, and headphones are used as detectors at frequencies 250 Hz to 3 to 4 kHz, and while working with a single frequency, a tuned detector is the most sensitive detector. The vibration galvanometers are useful for low audio frequency range, that is from 5 Hz to 1 kHz, but are commonly used below 200 Hz, which means that vibration galvanometers are useful for the low audio frequency range. Generally, below 200 Hz can be used. Okay, now coming to the construction. The simple AC bridge, which is the outcome of the Wheatstone bridge. You can see this is the figure which shows the DC bridge, and in DC bridge that resistances are replaced by the AC bridge in a AC bridge. Okay, so the source of excitation, that is in DC bridge, that is battery is there. In AC bridge, AC supply is there. There is only one difference, that is two differences. Resistances are replaced with the impedances, and supply, source of excitation, that is replaced with the AC supply. By using Wheatstone bridge, the impedances at audio and radio frequencies can be determined. Now, conditions for the AC bridge balance. So, for bridge balance, the potential of point C must be same as the potential of point D. That means there is a point A, B, you can say that A, B and C and D. So, the potential must be equal in terms of amplitude as well as in phase. Hence, the drop from A to C must be equal to the drop from A to D in both magnitude and phase for the bridge balance. That means that the voltage drop, the voltage is indicated with here E. Hence, the voltage drop across AC is equal to the voltage drop across AD. This is the equation, say it as equation 1. And the vector notation indicates the both amplitude and phase to be considered. Hence, that means According to the Ohm's law, V equal to IR. Here it is the AC bridge. Hence, the R is indicated with the replaced with the impedance Z. Hence, that is I1 Z1 is equal to the I2 Z2. This is say it is this equation has 2. When the bridge is balanced, no current flows through the headphones. Here we have connected the that is detector. That is we can use the detectors. That is headphones. So when there is when no current flows through the headphones, that is bridge is balanced. That means I1 and I3 is equal to I1 and I4 is equal to I2. And now the current through the impedance Z1 is equal to the, that is I1 equal to E by Z1 plus Z3 and I2 equal to E by Z2 plus Z4. This is the current flowing through the impedances, and that is say these equations as 3 and 4. So substituting equation 3 and 4 into the 2, that is I1 Z1 is equal to I2 Z2. If we substitute the equation, we can get E into Z1 by Z1 plus Z3 by E into Z2 by Z2 plus Z4. So E and E on the left and right side, both sides E is there, hence E can get cancelled. We can get if we cross multiply the equation Z1 into Z2 plus Z4 and Z2 into Z1 plus Z3. If we multiply Z1 into Z2 plus Z1 into Z4 is equal to Z1 into Z2 plus Z2 into Z3. So Z1 and Z2 both are cancelled, hence only the remaining terms Z1 into Z4 is equal to Z2 into Z3. Say this equation as 5. So this is the final balancing equation in the impedance form, that is Z1 Z4 is equal to Z2 Z3. In the admittance form, this condition can be expressed as Y1 Y4 is equal to Y2 Y3. The admittance is the reciprocal of the impedance. We have already seen in the previous semesters, that is admittance is indicated with the capital Y. So the reciprocal of impedance is the admittance, or admittance is the reciprocal of impedance. Now in the polar form, the impedances are expressed as Z1 is equal to Z1 into angle theta 1, Z2 is equal to Z2 angle theta 2, Z3 equal to Z3 angle theta 3, and Z4 is equal to Z4 into angle theta 4. So this is in the polar form. The above equation that can be written as Z1, already we have seen we can obtain the condition for the AC bridge balance, that is Z1 Z4 equal to Z2 Z3. In the polar form, Z1 into angle theta 1 is into Z4 into angle theta 4 is equal to Z2 into angle theta 2 into Z3 into angle theta 3. So here impedance parameters will get multiplied and angles will be added. That means the impedance parameters Z1, Z4 angle theta 1 plus theta 4, because the angles are added theta 1 plus theta 4, and that is equal to Z2 into Z3 angle theta 2 plus theta 3. This is the equation. Separately we can write magnitude and phase equation as Z1 Z4 is equal to Z2 Z3, and the magnitude, that is the condition above, that is called magnitude criteria, and theta 1 plus theta 4 is equal to theta 2 plus theta 3, that is the phase criteria. So the above condition for the AC bridge balance, magnitude criteria and phase criteria are satisfied. Now let us move on to the applications of AC bridge. AC bridges are used to find unknown impedances along with the associated parameters. and they are used in the communication systems and complex electronic circuitry. Majorly make use of AC bridges. AC bridge circuits are used in phase shifting and for the filtration of undesirable signals. That means to filter the unwanted signals, we can use the AC bridge, and also AC bridges are used for the phase shifting. And AC bridge is also used to measure the frequency of audio signal. Here, for measuring the frequency of audio signals, we can use the, that is a Wien bridge is used. So, and for AC bridge circuits, two balance equations are always obtained. That is, one is the magnitude and the other is the phase equation. Okay. Now, uh, let us summarize the topics we have discussed so far. First, we have discussed about the use of high voltage probe and working of high voltage probe and working of current probe, and also we have discussed the construction of AC bridge and conditions for the bridge balance. Now let us coming to the quiz part. The first question is high voltage probe. Before going to the quiz part, now let us I will give the brief introduction of the brief discussion what we have discussed about the so far. That is high voltage probe. High voltage probe is used above 100 kilovolts above that is that probe is made up of three components are there: probe tip, probe head, and cable, and there is a termination circuit is there. And next, a current transformer. We have seen the current transformer construction. So that current transformer construction is, we have seen current transformer. That is, the current probe consists of a current transformer. Only the difference is the ferrite core in current probe. Current probe generally it works on the principle of the electromagnetic induction, because as it works on the principle of the current transformer. Okay, and later we have discussed the conditions for the bridge balance, and that is the condition is what is that condition? That is Z1 Z4 is equal to Z2 Z3, and angles theta 1 plus theta 4 is equal to theta 1 theta 2 plus theta 3. Now coming to the quiz part. High voltage probe is used to measure the dash: voltages, resistance, C capacitance, and D none of the above. High voltage probe, in the name itself it indicates the high voltage probe. That means the voltage, we can measure the voltages. That is high voltage, high voltages. For AC current measurement, dash probe is used. AC current probe, DC current probe, AC voltage probe, and DC voltage probe. The correct answer is AC current probe. Hence the answer is A. In the simplest form, an AC bridge consists of dash. A source, detector, amps. B arms and source. C source and detector, and D arms and detector. So in the simplest form, AC bridge consists of dash. So we can see in the figure that if we go to the slide, that is AC bridge circuit. First, we have already seen construction of AC bridge. You can see here in the simplest form, it consists of arms, source, and detector. That is, it consists of 4 arms, and each arm consists of impedances, and source of excitation is AC supply. And balance detector, for balancing detector we can use the headphones, that is 250 Hz to 3 to 4 kHz, and tunable amplifier circuits and vibration galvanometers. So the correct answer for this question is, that is the source, arm, and detector. Okay, so the answer is A. Source is dash. Just now we have seen source is for AC bridge, the source is dash. That is A DC supply, B AC supply, C mixed mode supply, D high voltage supply. So for AC bridge the source is AC supply. So the correct answer is B. Now coming to the next question. At high frequency source consists of dash. So for high frequency we have the options A amplifiers, B regulators, C oscillators and D op amps. For high frequencies, electronic oscillators are used as source. So the answer is C. The next question is, commonly used balance detectors for AC bridges are headphones, tuned amplifiers and vibration galvanometers. Is it this statement is true or false? So we have already seen in the figure AC bridges balance detectors. For AC bridges the balance detectors are headphones, tunable amplifiers and vibration galvanometer. So the statement is true. The answer is A. Now the next question, that is the seventh question. What is the frequency range for a headphone used as a detector? That means to use the headphone as a detector, the frequency range is from dash. So options: 20 Hz to 20 kHz, this is the audible frequency range. 10 kHz to 1 MHz, and C 10 MHz to 1 GHz, and D 250 Hz to 4 kHz. We have already seen in the figure the headphone frequency range is from 250 Hz to 3 to 4 kHz. So the correct answer is D. And the next question, for a single frequency value, the most sensitive detector is dash. A tuned detector, B vibration galvanometer, C headphone, and D oscillator. So for a single frequency tuned detector, single frequency, that means tuned detector is the most sensitive detector. So the answer is A. Next question, ninth question. Vibration galvanometers are used for A very high frequency, B very low frequency, C low audio frequency, D high audio frequency. Vibration galvanometers are used as detectors whose basically useful for low audio frequency, which is ranges from 5 Hz to 1000 Hz, but are commonly used below 200 Hz. Hence the answer is C. Vibration galvanometers are used for low audio frequency range, which is preferably 200, below 200 Hz. Keep in mind. And next the question is, AC bridge is an outcome of dash. So A Kelvin bridge, B Megger, C de Sauty bridge, D Wheatstone bridge. A Kelvin bridge. Kelvin bridge is only used for the measurement of low resistance, and Megger is the measurement of very high resistance, and de Sauty bridge is useful for the inductance measurement. And only here the next option is only the Wheatstone bridge. That is Wheatstone bridge is the outcome of the, that is AC bridge is an outcome of the Wheatstone bridge. Here the option is given wrong, so the correct option is D. Okay. Now the frequently asked questions are, that is, explain the use of high voltage probe, draw the circuit of the current probe and explain, and explain the construction of AC bridge, and state the conditions for the bridge balance. So these are all the questions frequently asked in the exam, and Thank you very much for listening and watching the video. And I hope that this topic it will help you with what I said from the beginning. So thank you very much. If you have any queries, feel free to interrupt. My email ID is sravanti.kapu sravandhi.kapu @gmail.com. Thank you. Signing off, Shravanti. Goodbye.